vector kinematics for velocity and acceleration. We'll be using unit vector analysis to determine the velocity and acceleration of a particle. So we have a particle's position as a function of time is given by this equation. We would want to determine the instantaneous velocity of this particle. So remember, if we take the first derivative of the position with respect to time, we can determine the instantaneous velocity equation. So remember, if there's a t, we multiply the exponent on the t by the number in front and then subtract 1 from the exponent. So our first derivative is 5 meters per second. T squared times 6 is 12, and we're left with t, and that's our I function. The 7 meters drops out because t is not involved. Multiply 3 times -3 to give us -9. Drop the exponent by 1 to give us our j value. That's our particle's instantaneous velocity. We can determine the acceleration by taking the first derivative of the velocity. That's also the second derivative of the position. So again, if no t is involved, we drop that variable out. So the 5 meters per second drops. T time has an exponent of 1, so 12 meters per second squared is our I value. T squared times -9, we have -18 multiplied by t for our j value, and that's our instantaneous acceleration. Let's evaluate our instantaneous velocity at t equals 2 seconds. So we're going to use 2 every time we see the t variable. So we have 5 plus 12 times 2 for our I value, which gives us 29 meters per second I. For our j value, we have 2 squared times -9, which gives us -36 meters per second for our j value. This question asks us to find the magnitude of this instantaneous velocity. So we have our equation, and now I've drawn a little sketch to show the vectors in the proper direction, and we're just going to use Pythagorean's theorem to find the resultant. So 29 squared plus -36 squared gives us a resultant of 46 meters per second. We're going to evaluate A at t equals 2 seconds. So again, using 2 anytime we see a t, our I does not change at all, and our j value is 2, here we are, 2 times -18 to give us -36. And this is our equation for the instantaneous acceleration at t equals 2 seconds.